thank you for coming here in such large numbers. Okay, so today I will tell you something about AI editors, how they work and how to master them. And you might ask, like, why is it important? And I believe you've heard it before. Like, you won't be replaced by AI, but somebody that's using AI. And I believe, like, understanding these tools is very important if you want to be efficient at your work. And I believe, like, currently, maybe like 10 or 20% of people actually know how to be productive using these tools. But the bar is getting higher, and if you fall behind, I believe you will become sort of obsolete, like, because human programmers that can't efficiently use AI maybe in 2 or 3 years will just become, as I said, obsolete. I mean, maybe you could move to higher, like, management positions and stuff, but if you are talking about writing code, like, LLMs are so good at it that you can't pass on it, I would say. All right, so about me. I was a front-end developer, then full-stack developer, then cloud architect, and 5 years ago I started a company called StackTape. We are doing like a platform as a service built on top of AWS, so it's basically like Heroku in your own AWS account. And yeah, recently we started developing a new product called AppTape, which is basically a migration platform that can take a legacy application, for example, written in PHP, yeah, mostly PHP, and rewrite it in modern TypeScript. And yeah, when I was researching like how to implement this, yeah, I literally analyzed all the open source projects that were out there, so all the different code editors, and I've looked at the techniques that they are using, and I tried to copy them or just get inspired by them. And I also analyzed some of the closed source projects, because there's actually a repository that shows system prompts even of the closed source project, because you can actually, hack the LLM to tell you the system prompt of it. So it's basically a public domain. And also recently somebody reverse engineered how Cursor works, like behind the scenes, what it does, like how it indexes your code base. So I have some interesting stuff about it as well. So yeah, but first, like, there are multiple usage patterns of using AI in your development workflow. Some people are simply copying the code snippets from the web UI, and yeah, it works. But yeah, for certain tasks, it's like not very efficient. And then some people use Cursor or like these AI code editors just for the autocomplete, which is very good. By the way, Cursor is, I believe, the only AI editor that has their own autocomplete model. So it's like very fast model. It very quickly re-indexes your code base, so that you can get very fresh suggestions. This is some people use only this kind of working with AI editors. But when you open the Command L, like in Cursor, when the chat shows up, then you need to start typing what you want to do, and you're basically vibing sort of with your editor, like or with the AI, and the AI is writing the code. And this part we actually need to learn and how to be efficient at it. And yeah, and then in the near future, I believe we will all need to have our own agentic workflows or our own agents. The last presentation was about creating such agents. And yeah, I believe in the future we will need to have these, or like maybe they will be on a company level, so somebody in your company will set them up, but yeah, you will need to have them to be efficient. Okay, so there are like a lot of different tools. These are actually like there was a lot of funding going into these different AI code editors. I tried to get their estimated market share. Yeah, these are the big ones. But I would suggest trying out the small ones, because the innovations usually happens on the on the lower end of this list. Yeah, and as I mentioned, this is the repository that shows you, the system prompts of different editors. So, for example, we can check like how Cursor does it. So let's say I want to see the memory prompt And yeah, I can exactly see like what it does. So yeah, as I said, this is becoming commoditized, like the prompt engineering here. So yeah, let's get back to it. And yeah, so first thing, like if you want to master AI editors, we need to master context. Context is very important. Some would say it's the only important thing in when you're developing, or working with AI applications, because the smaller the context, the more relevant the result will be, and also faster, less, you will use less tokens, and it will be also cheaper. So first thing that, or first technique that these AI editors use to search your code or work with it, or just basically put your code into context, is using semantic search. I will talk about it later. The second one is rip grab, which is basically like just regex-based grabbing of your whole code base. And the third thing, and I believe we should do this more, like if you want your AI to perform certain tasks, just I believe a lot of times very important to, or it's advised to manually reference everything that the AI will need. Then when your context fills to a certain size and it starts to hallucinate somehow, or just the results are not so good, there's a technique called summarization, where you basically tell it, okay, tell me like what happened in this one chat session, and then you just paste it to another one. Some AI tools just have like one button to do this for you, and they have actually like optimized prompt to summarize the previous conversation. But if you're not using a tool that does this, I really recommend it. And yeah, maybe you've heard about lost in the middle problem, where LLMs are good at following instructions at the start of the conversation and at the end of the conversation, but some instructions in the middle might get lost. So just be aware of that. And now I will explain how semantic search works. Semantic search, for example, when you or the LLM ask a question like, where is authorization logic for order service defined? Where in this code? And because like, if you didn't have this semantic search code, it could just do a regex search, so to basically just search the whole code base for the keyword. But yeah, that doesn't work like that well, because the authorization logic could be spread amongst many other places, and also you can't put the whole code base into context. And then, yeah, so we need an intelligent way to put relevant code chunks into context, and this is where the semantic search comes in. I actually looked at the reverse engineered cursor pipeline and understood it, and I also re-implemented it myself. So yeah, I will just explain like how it works on a high level. So let's say you have a some file, let's say a file. Like it indexes your search by files, and the file can have like classes, functions, variables, and so on. And the first thing that happens is that these are parsed using a tree stitcher. So for example, we can parse all the function identifications in a file, and then we can take the relevant chunks of the code. For example, where we can be interested in function declarations, or class declarations, and variable declarations. And then we add some metadata to these chunks. So for example, we have a chunk that defines like greet function. We add like metadata to it. For example, like what file it is in, what lines are it on, and yeah, some basically like a line start and line end. And then we send these chunks to an embedding model. There are a lot of embedding models. By the way, this is very fast process. It takes just a few milliseconds, and is also very cheap. So you can rerun this very quickly. And what we get back are the vectors. I could also explain like how vectors work. I initially thought that it might mean like every vector, every value in the 1,536 long vector array. So I thought like every value references some like a characteristic. For example, like, is this animal, or like how related is this word, or how related is this semantic chunk to animal or something. But it doesn't work like that. It's way more complicated, and we basically can't tell like what vectors mean. We don't see them. We might understand like maybe 3% of the vectors like and their meaning, but in reality we can't know. So we just have to trust the LLM or we have to trust the AI that it knows what it does. Then, when we have these vectors, we can save them in a vector store. And we can also save them in memory. It's the fastest way. And the only requirement is that we need to save it somewhere or like in some store that can do so-called cosine similarity search. And yeah, this can be also like in-memory search. And for example, in TypeScript, there is a LangChain library that allows you to perform this similarity search from the data that are saved in memory. So, okay, so now we have our vectors saved in the database, and now we actually need to, retrieve it, like retrieve relevant chunks of the code. So, what happens here is like we again embed users or like LMS query. For example, the where is authorization logic query gets embedded again. Then we perform the similarity search, get results, and we filter only those results that have like some predefined similarity score, so we don't put in like too many irrelevant chunks, and then we return back all the chunks that are relevant. So for example, if authorization logic is, I don't know, maybe in every route or logic or API route logic, then we return every file that with this API authorization logic. Okay, as I mentioned, there's like a reverse engineered Twitter thread that explains how Twitter or how Cursor does it, and yeah, basically they do it mostly in the same way, but they save it on their servers, and that's basically what you're paying them for, because they handle this rack pipeline for you. But you can totally recreate this locally, and I believe it's also way better to recreate it locally, because one drawback of using Cursor is that they re-index your code base only once in 10 minutes. And so, for example, when you switch branches, then yeah, sometimes you get very irrelevant context, and the LLMs start hallucinate because they understand like why is it not there? It was just there. So yeah, I believe we need to do way more than once in 10 minutes. Okay, another technique or like is mastering agent rules, and sometimes these rules are like cats, because they sort of know what you want them to do, but they just ignore you. They do it in their own way. Yeah. So, and just to start, so if you have an existing project and you want to start using these rules or agents.md, agents.md is actually cross AI editor rules file. And yeah, for example, Cursor has their own format, but these agents is just a standardized way of doing it. But for example, in Cursor, what you can do is /generate Cursor rules, and it will observe all the patterns that are already used in your existing projects and create rules based on them. And so when you want to make some changes, it should follow those rules. Yeah, one technique. Like for very important rules that must always be followed, what you can do is use XML tags for them and just tag them like important rule and put them in there. Or if there are some like very important rules, then you can just reference the file manually using just using the way you do it in your editor. And also when you are defining these rules, it's better to use globs to match the files you want than any other ways that you can do it. Okay, technique three is choosing the right model for the task. And yeah, it depends on the task. For example, if we only have small tasks, like very, very simple, one file task, then it's way better to use small models. And by the way, there are also like open source models. Base model is, I would say, GPT OSS 120 billion parameters. And actually they can run cheaper and way faster than if you run, you can basically run them on something called GrokQ or Cerebras, and I can actually show you how quickly they can run, if I will be able to click on it, yes. So, for example, Cerebras is a company that specializes in inference. They have some like specialized hardware, and basically what this graph shows is that they can do 3,000 tokens per second, which is like, this is just instant answers for, small tasks. So, yeah, that's it. Let's get back to it. And from experience of people that I've talked to or Reddit threads that I read, if you're performing UI or design tasks, then GPT-5 codex is the best model for it. And for everything else, just use Claude Sonnet 4.5. Yeah, it came 2 days ago, and it's like, I would say it's a huge jump, but yeah, let's see, because when Claude 4 came out, it was also very good, and then somehow its performance degraded. So yeah, let's see. Yeah, this is another technique of having up-to-date docs. We've talked about this. It's the Context 7 project. I can actually show you. Okay, not like this. Okay, I guess I can't click on it. Yeah. So for example, yeah, there are a lot of libraries here. So yeah, let's say Next.js. And let's say I want to, yeah, how to do data fetching or something, right? I can ask the docs what I want to do, and I get all the relevant code snippets back. And yeah, this is not that handy if we are talking about searching it manually, like for humans, but it's very useful for LLMs. And so there are a lot of MCP servers that are doing this. And but if you have MCP server that can call Context 7, don't forget to put the rule into your AI rules, which says like if or like every time that you want to access some documentation, check the version of the library that we are using in package.json or something, and then ask the Context 7 to get docs for that version of the documentation, because what actually happens is like open source project usually, or they index every version of that package, and yeah, if it changed, so it will have exact version, and yeah, so less hallucination, more relevant answers. Okay. Yeah, we've already talked about MCP servers here today. I believe that there are a lot of directories nowadays that you can find, where you can find like very handy MCP servers. Actually, and I recommend browsing them, because there are so many small little things that can improve your workflow. But it heavily depends on what you're working on. So I can't recommend like very specific ones. But I would say like everybody should be able to find at least 3 very handy there. And yeah, the last recommendation is that when you are writing your code using AI editors, a lot of slop gets in there in the code base. Sometimes, yeah, maybe some code that doesn't follow your code rules, or like your folder structure or anything, and it's advised to remove technical debt regularly, and that can be done by refactoring. You can actually tell the LLMs to refactor, and if the refactoring isn't like very complex, then yeah, they can do it themselves. But why I'm talking about this is because in the age of AI, I believe there will be way more technical debt, and also if you have a lot of technical debt, then the AIs will just start hallucinating a lot more. And yeah, that's it for me. Thanks for your attention.